There are many common views used to communicate and analyze systems. These views aren't independent. In fact, they are bound together by a common metamodel. This metamodel is a foundational element of good model-based systems engineering. One can visualize this by way of a cube. Let's take a look. Let's start at the top of the cube. This metamodel represents the core information required to successfully engineer a system. This is how the information is organized in the model. The remaining sides display the domains, requirements, behavior, physical architecture, the design journey, and analytics, through which we organize and communicate the data that populates our model. The requirements side highlights a variety of ways in which we can enter data into the model or display the data that is there. Called views, these vehicles allow us to display and modify our data. Which view we choose depends on who will use it and how it will be used. As you see, different views represent different subsets of information from the model, but a good metamodel keeps everything consistent. These behavioral views connect information with the highlighted pieces of the schema that contain the information about how the system being modeled will behave, the functions being performed, the objects and data being exchanged, and more. Here we have views into the physical architecture that communicate data regarding the physical structure, the parts and their interconnections, that perform the system behavior or functions. Good model-based systems engineering is about more than the resulting system specification. It's about capturing the design journey, the alternatives considered, the decisions made, concerns addressed, risks mitigated, programmatics, and more. This information is integrated throughout the model, reflecting both design journey and result. Systems engineering requires both architecture and analytics. These views represent the design parameters and interrelationships which drive system performance, enabling you to bring the appropriate degree of rigor to the architecture and design endeavors. Again, they are tailored to particular audiences and purposes, enabling you to analyze both behavior and physical architecture to verify requirements are satisfied. Requirements, behavior, physical architecture, and analysis. A good metamodel not only serves as the foundation for analysis and communication, but it serves as a roadmap as well, reflecting what you know and what you don't. By being mindful of these elements as you travel along your design journey, you're bound to have insights.